We're graphing the system of linear equations to find the solution, and given this system, I want to find where they cross. So let's graph by hand. This entire packet will be graphed by hand in this video. To see the calculator tricks, look for the video under this one. First equation, plot b equals -1. The y-intercept of the first equation is -1, so plot -1 on the y-axis. Second part, graph m. M is 2. Now we have to put it over 1 so that it is in fraction form so that we can graph the slope. They are both positive, so that means to go up and then right. I go up 2, right 1. Continue that pattern so that you can graph the points going up, and to graph the points below, do the opposite. Down and right. Down and left. Down and left. Down and left. You gotta do the opposite. Okay, let's do the second equation. On the same graph, we want to plot the y-intercept of the second equation. B equals 5, B equals 5. Plot 5. Now let's plot the slope. Slope is -1. Put it over a +1. This means the top is negative, not the bottom. So you will go down and right. So down and right, down and right. Here's the solution, but continue graphing the line so that we can see the entire system. And when you finish the pattern, you see a big X and the dot in the middle where they meet, where they cross. That is our solution. Okay, now let's look at the table version of this system. They both have in common 2, 3. So therefore, that is the solution just by looking at the table. I want you to see the 2, 3 on the table for each system. Number 2. Graph the system of linear equations to find the solution. Okay, this should be easier now because we've already practiced graphing by hand. I do notice a mistake here. It says the y-intercept is -3, but I left it -1, so let's change that to -3. So start at -3 on the y-axis, and now graph the slope. Up 1 and over 3. Continue that pattern. Do the opposite to graph the other side of that line, which would be down and left, down and left. Now that the first equation is finished, let's graph the second one. If you graph 4 and then graph 2, you are incorrect because this one is not solved for y. We have to first put it in y equals mx plus b form before we can graph it. So how do you solve for y? Move 2x to the other side by subtracting him. Once he is subtracted, he is no longer on the left side. Remember, you're subtracting because he's positive. Now that he is on the other side, these two become -2x plus 4. We can now graph the second equation. Start at 4 on the y-axis, 1, 2, 3, 4. Now graph the slope. We have a negative slope, but we do not go left for the 1. The 1 is positive, so you must go right. The 2 is negative, so we will go down for the 2. Down 2, right 1. Continue that pattern and see where they cross. And you will see that they meet at 3, -2. That is their solution because that is where the two lines cross. When you look at the tables from this system, what do you see? Well, let's look at the tables. Do you see the same solution? Yes, you do. Now, I do want to say there are times you will have a solution that you don't see on both tables, and that does not mean that the solution, that it doesn't have a solution. You just may have to do more work to find that solution. Okay, I was thinking about the packet we did so that I could show you, but I don't have it handy, so maybe I'll come back to it at the end. We are not going to go over this page during this video. We'll come back because these are the calculator tricks. Starting with number 4. Let's graph these two equations. Start with b, which is -2, on the y-axis. Graph the slope, which is 1 over 3. Go up 1 and over 3. 1, 2, 3. Remember, you're counting the boxes. 1, 2, 3. Continue the pattern. 1, 2, 3. To graph the other side, do the opposite. So instead of up, we go down. Instead of right, we go left. 1, 2, 3. We're counting the boxes. And then the dot goes at the end of the boxes. Go down. And what I'm doing is I'm kind of looping. See, I'm counting that box 1, that box 2, counting that box 3. Please use a straight edge to connect your graph so that your paper comes out nice and neat. Okay, now we need to graph y equals -1. You should remember that is a horizontal line. So go to the y-axis and graph -1. Not a dot, a line. And we see that the two equations cross at 1, 2, 3, -1. Number 5. Let's graph 1/2 x minus 4. Let's go to -4. On the y-axis, 1, 2, 3, 4. Let's go up 1 and to the right 2. Up 1 to the right 2. Up 1 to the right 2. Do the opposite. Connect with a straight edge. Let's graph x equals -1. And this is where people get confused. They think all of them are horizontal, not x. X would be vertical. So go to -1 on the x-axis, not the y-axis, and draw your line. The solution is here. Now, since this video is being done by hand only, we could only guesstimate. I intended for number 5 to be a calculator problem, but I want to do this by hand. So I know the x value is -1. The y value looks like it could be halfway, but I'm not sure. So I would take the number that I choose and plug it into both equations to see if it works out, which is -4/5, and it does. I'm not going to show that part. I know I said it's all by hand, but I'm not going to show that one. Please don't be mad. Okay, number 6. We want to go to -3 on the y. 1, 2, 3. And put that over 1. And go up 2 and over 1. 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 Do the opposite to get the other side. Use your straight edge, ruler, ID badge, ID. Now x equals 4. That is a vertical line. 1, 2, 3, 4. And we see that it crosses here, which is 1, 2, 3, 4 for the x. 1, 2, 3, 4, 5 for the y. If you also look on the table, you'll also see 4, 5 on both tables. So that's our verification we did it right. Number 7, y equals 3. I'm going to start with that one. Y equals 3 is not vertical, it's horizontal. 1, 2, 3. If you understand this, you can fast forward to the next example, number 8. If not, please continue watching. B is -1 for the next one. So -1. Put this over 1, so I'm going down 2 and right 1. Remember, the 1 at the bottom is positive. You should already see the solution. And it is -2, +3. And if you look here, that is exactly what the table says the solution should be. Number 8. They are both solved for y. I'm ready to graph. Let's go to 1 on the y, and the slope is 1, so up 1 and over 1. To do the other side, do the opposite. Let's connect. Okay, second equation, go to 5 on the y. 1, 2, 3, 4, 5. And put this over 1, so we're going to go down 3 and over 1. Down 3 and to the right 1. I should be saying right and not over. Down 3 and to the right 1. Connect with the straight edge, and you should see that the equation, the solution is 1, 2. And the table proves that to be true. Okay, number 9. Number 9, the first one is -2. That's B. The slope is 1. So up 1 over 1, up 1 over 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Down 1 to the left to do the opposite. And we use our straight edge and we connect. Now let's do the second equation. It's not solved for y, guys, so you have to subtract it because it's positive 2x and move him to the other side. That cancels. I now have y equals -2x plus 1 because 1 is positive. Go to 1 on the y and graph -2. That means to go down 2, but we're going right 1 because the one we're putting under the -2 is positive. And do the opposite to get the other side of the line. And now I have used my straight edge. I see where they cross. They cross at 1, -1. For those that see the mistake, on number 9, that should not say -5. That should say 1. Number 10. I'm going to start with the bottom one because the top looks weird. So, start at 1. Go down 1. Uh-oh. Do I go left 2 or do I go right 2? This negative sign only belongs to the top, and that is all the time. I don't want to say you can't write it in the bottom, but I will say this. Do not write it in both spots. I'm going to just tell you to assign the negative to the top number always. That means -1 over +2. That means down 1 and right 2. Do the opposite to do the other side. I missed that. I'm going to get a marker because I totally missed that. Let's redo that. Okay, it's a little better. Okay, so now that I have my correction made with my marker, let's do number 1, the first equation on number 10. How do I solve x plus y equals 0 for y? Move the x over. It's positive, so subtract him. Y is now alone, You don't have to write negative x plus 0 because adding 0 is not going to change anything. But if you want to write it so that you see the y-intercept, go for it. B is 0, so that means I start here. And now I am going to plot my slope. Negative 1 over positive 1. Down 1, right 1. Down 1, right 1. Now, as I plot this down here, I see it's going away from the line. That means to see the intersection, I need to go that way. So, up 1 and left. Up 1 and left. Up 1 and left. And I think you just found the intersection. Let me try to be a little more careful. I guess after doing 10 of these, your graphing gets a little sloppy. So I can't be too mad when you guys get a little tired towards 10, because I did. 1, 2, negative 2 is the x, 1, 2 is the y. And it is also on the table. Number 11, oh boy, it's getting fun, isn't it? We need to solve them both for y, so let's get to working. Negative x on both sides because I need to get rid of the x which is positive. Guys, don't always subtract the x term. We're only subtracting them because the examples I have given you thus far are all positive. So I'm hoping that later on we have a negative that we will not subtract, we'll have to add. So now we have y equals negative x plus 4. I'm going to go to 4 on the y-axis, 1, 2, 3, 4, and plot the slope. Down 1, right 1, down 1, right 1. There we go. This is so much fun. Alright. Now we solve the second one. 2x plus 3y equals 9. Subtract 2x, subtract 2x. 3y equals negative 2x plus 9. Divide by 3. Y equals negative 2/3 x plus 3. So we need to start at 3. Now, if that was done too fast for you, stop and rewind. 3 is here, 1, 2, 3 on the y-axis. It tells me to go down 2, but right 3. 1, 2, 1, 2, 3. And I've already found the solution. Down 2 and 1, 2. But I want to keep graphing my points so that I have a more accurate line. Okay, and the solution is 1, 2, 3, 1. Let's see, are we right? Yes, we are. 3, 1. And 3, 1 is on the table. Let's do number 12. It gets interesting. We still have to solve them for y, but we are not dealing with one solution anymore. We're dealing with no solution and infinite. So I'm going to go ahead and solve this bottom one for y. Tell me, what did I do wrong? I see this a lot. You guys immediately start dividing, and that's incorrect. You need to ask yourself, is the x in the spot that it needs to be in? If your answer is yes, then you just divide if there's a number in front of y. But if x is not where it needs to be, you have to move him. So this is wrong. You should have subtracted 3x on both sides. And no, that is not 0. It's negative 3x plus 3. Divide by 3. Cancel. You get, that's 1, and it's negative, plus 1. So we go to 1, and then graph negative 1, down 1 right. Do the opposite. Again, the parts of this video that you understand, you can fast forward it. Go to the next part. Some people may need to see all of it. Now we have to change this one. Subtract x, y equals negative x plus 6. And then we start at 6, 1, 2, 3, 4, 5, 6, and go down 1 and right 1. When you connect it, if you notice, they don't cross. And what I had to do was be careful about the way I wrote the answers that you circled. I knew you knew what parallel lines were. These are parallel. So I wanted to put that there so you would know to circle this one, but I don't want you to ignore the words after parallel lines, because the point of this problem is to help you to understand what no solution problems look like. I am no solution because I am parallel. That's what no solution looks like, because they don't cross, so it doesn't have a solution. To have a solution, they must cross. That's why all of these had answers, because they crossed. This doesn't. That's why it's no solution. And how do we know that they're parallel? You should remember, when I have the same slope, this has a slope of -1. This has a slope of -1. When the slopes are the same, you have parallel lines. And if parallel lines never touch, you also have no solution. Number 13. This is helping you to practice to solve for y, because that's what you guys have been struggling with, is solving for y. So I am still solving for y. A negative divided by a negative is a positive. A negative divided by a negative is a positive. Now we go to 1 and graph a slope of 1. Up 1 over 1, up 1 over 1, up 1 to the right 1. Do the opposite, down, left, down, left, down, left, down, left, down, left, down, left. Connect with my straight edge. I know you're tired. This is probably a longer video than I wanted it to be, but I didn't want to split it up. So let's now do the top one of the top first equation of number 13. Oh no, I'm sorry. We just did the top equation. Let's do the bottom equation. So we don't divide by 2. We subtract 2x from both sides. That cancels. And no, this is not 6. That's negative 2x plus 8. We divide by -2. Cancel, cancel. Y equals positive 1x minus 4. We come to -4. 1, 2, 3, 4. Go up and over. And as you can see, the lines are also parallel. And they have the same slope. There's a 1 there. Slope 1, slope 1. Parallel lines. Thank goodness one of them is already solved. Go down to -2. Go up and over. Up 1 over 1. Do the opposite, down and left. Let's connect. And now let's solve. Getting tongue-tied there. Now let's solve the second one. Add x. Finally, y equals x minus 2. So we start at -2. Look, we've already found the solution. Down, up 1 over 1. Oh, you thought that was the solution, didn't you? What do you notice is going on? That's a solution. That's a solution. What's going on? Both equations match. So the only way to show that I have graphed this twice is probably to use a different color. I purposely made you think that this was the solution, because I know that's what you would think, but it's not. What we have is what we call infinite solutions, because we have graphed the same line. This and this are exactly the same thing. So when you graph it, You're graphing one line, and you're just graphing it twice. When that happens, that's what you call infinite solutions. Let's do number 15, which is the last of the graphing. And we do have to solve these. So 6x plus 10y equals 60. Let's subtract 6x. 10y equals negative 6x plus 60. Divide by 10. And we're going to do 3. Negative 6 divided by 3. No, 2, I'm sorry. Negative 6 divided by 2 gives us 3. And this divided by 2 gives us 5. And then this reduces to 6. So now we go to 6. 1, 2, 3, 4, 5, 6. Go down 3. 1, 2, 3. To the right 5. 1, 2, 3, 4, 5. And we have enough to connect. Now we have to solve this one. Negative 3x, 5y equals negative 3x plus 30, divide by 5, y equals negative 3 fifths x plus 6. Now you start off with plus 6. You go down 3 and right 5, and guess what? It's the same line, which means we have what kind of solutions, guys? Infinite solutions. Number 6 is a little different. Is the ordered pair for 1? Yes or no? Some of you are going to want to plug this into menu 3-2, and there's nothing wrong with that. This is what I would suggest. Plug in the x in the x spot. Plug in the y in the y spot. This is 2 because 2 times 1 is 2. What is 4 plus 2? It is 6. It is time for you guys to come to class, but I'm going to keep talking. Plug the 4 here. Plug the 1 here. What is 4 minus 1? It is 3. That means, yes, this is a solution. Is the ordered pair negative 1 comma 2 for this? Let's plug it in. 3 times negative 1 is negative 3. Minus 2 times 2, which is 4. Will that give me 5? No. Therefore, this is not the solution to this system. I wanted you to draw what one solution looks like, and I drew it. Are the lines perpendicular? If I check it with my protractor, I know you don't have one at home, but if I checked it, it is a little off. So the answer is no. It's not 90 degrees. Let's do number 9 and 10. 2 more and we're done. What does no solution look like? Just want you to sketch it. Parallel lines. Same slope. Parallel lines. And of course, that's my 4th period messing up the video, standing outside the door, yelling. Thank you, Mr. Lewis. Last problem. Draw what infinite solutions look like. And that is the same line drawn on top of each other. So he is going to be so mad at himself, and so is his parent, because they know who that is, and he's on the video disturbing. That's okay. This is what infinite solutions look like. We are now complete. I'm sorry the video is so long. Fast forward to what you don't need. Watch what you need, and the next video will show you the calculator trick.